In this video, I'm going to show you how to solve a radical equation that's one of the more tricky kinds of radical equations. I've got the square root of negative 7x plus 2 plus x equals 2. A general trick for solving radical equations is to try to isolate one of the radicals on one side of the equation. So for instance, with this example, I'm going to subtract x from both sides so that I'm left with just the stuff under the radical on one side, negative 7x plus 2 all under a square root, equals 2 minus x. Now that I have the radical alone on one side, I can square both sides of the equation to undo that radical. I will square both sides, and remember, we're squaring both sides of the equation, which means that I'm going to have to FOIL this side. On the left, the squaring undoes the square root and leaves me with negative 7x plus 2. But on the right, 2 minus x squared means 2 minus x times 2 minus x, and we'll have to FOIL that out. So negative 7x plus 2 equals 4 minus 2x plus x squared. Now I'm going to clean this up a little bit and make it look more like a quadratic equation. I've got negative 7x plus 2 equals 4 minus 4x plus x squared. Then I can move, I would like to keep the coefficient on the x squared positive, so I'm going to move the 7x and the 2 over to the right-hand side. That leaves me with 0 equals 2 plus, plus 3x plus x squared. And just out of habit, I'm going to go ahead and rewrite this with the x squared first, so that I have x squared plus 3x plus 2 equals 0. Now, I should be able to deal with this quadratic. It should factor. And sure enough, I'm looking for factors of 2 that add up to 3. There's really only one option here, a 1 and a 2. Then I can set each piece here equal to 0. X plus 1 equals 0. X plus 2 equals 0. Which means finally that x equals negative 1. Let's adjust this a little bit so you can see better. No? And x equals negative 2. Now that we've found our two solutions, we should double check that they're actually in the domain of the original equation. When you're solving a rational equation, it's possible to end up with extraneous solutions. That is, through no fault of your own, one of the two solutions, or however many solutions that you get, might not actually work back in the original equation. So we could either plug in each of our solutions to double check that they're correct, or we can make sure that they're at least within the domain of the original equation. So the possible problem in a radical equation is that we could be trying to take a square root of a negative number. So to find the domain, we want to make sure that all of the stuff under the square root is always positive. So negative 7x plus 2 needs to be greater than or equal to 0. Now we can solve this little inequality, getting negative 7x is greater than or equal to negative 2, dividing both sides by negative 7. X is less than or equal to 2/7. Notice that when we divide by a negative, we reverse the direction of the inequality. So this tells me that any solutions I found that are less than or equal to 2/7 are probably correct unless I made a mistake somewhere. So it looks like these two really are good solutions because they fall within the domain.